Okay, this is quiz 7. So we want to calculate the limit as t goes to, this is problem 1, as t goes to infinity of this messy thing, t minus t squared root of t divided by 2t to the 3 halves plus 3t minus 5. So we do our reality check first. As t gets large, we have to think about what happens in the numerator. This goes off to infinity, but t times the square root of t, you've got to think of that in exponential form. So it's going to be useful to look at that as t times t to the 1/2 instead of the square root. So this is t to the 1 times t to the 1/2, and you add the exponents when you have the same base. So this is 1.5 or 3/2 as the exponent of t. So this is really t to the 3/2 power being subtracted from t, and t to the 3/2 is bigger than t to the 1. So this thing is going off to negative infinity because of that minus there. So the second guy is bigger than the first guy. So it's the second one that dominates. So the numerator is going off to negative infinity. The denominator, on the other hand, is getting big, big, big. It's going off to positive infinity. So you're going to have a negative infinity over positive infinity, which is bad news. We can't tell what's going on. But we have a trick, which is to multiply top and bottom by 1 over the highest power of t. So that would be 1 over t to the 3/2 power. So you're going to multiply top and bottom by 1 over t to the 3/2. So this is going to give us the limit as t goes to infinity of what? Well, you're going to have to distribute this 1 over t to the 3/2. So 1 over 3 to the t 3/2 times t. This is t to the 1. So you're going to end up with, well, let's write it this way. T to the 1 times t, or divided by t to the 3/2, which is going to give us t to the 1 minus 3/2 using the laws of exponents. And 1 minus 3/2 is negative 1/2. So this is t to the negative 1/2, or 1 over square root of t. So on top we have 1 over square root of t. Minus, now this is good because 1 over t to the 3/2 is going to cancel completely this guy, because remember that guy is really t to the 3/2. So 1 over t to the 3/2 times t to the 3/2 is just going to give us 1. Down below, this is 2t to the 3/2 divided by t to the 3/2 just gives us 2 plus 3. Now we have our t divided by t to the 3/2. We just did that. That's going to give us 1 over square root of t, so it's going to be 3 over square root of t this time. And then the minus 5 is going to give us minus 5 divided by t to the 3/2, or divided by the square root of t cubed. And you can write it this way, or you can write the square root of t quantity cubed. It doesn't matter, because square root of t times square root of t times square root of t is the square root of t cubed. Laws of radicals. Okay, at this point we can calculate what happens as t gets large. 1 over square root of t is getting small. That goes to 0. 3 over square root of t is going to go to 0. And 5 over square root of t cubed is also going to go to 0. All of those denominators are getting huge as t gets large, so they go to 0, because the fraction gets small when the denominator is big. So the limit is just minus 1/2. So we have a horizontal asymptote for this function on the right of y equals negative 1/2. Okay, that brings us to the infamous number 2 from quiz 7. In number 2, you were asked to find the limit as x goes to minus infinity of x plus the square root of x squared plus 2x. Okay, first reality check. What happens as x gets small negative, going off to negative infinity? Well, then obviously the first term is going to negative infinity. Inside here, you're squaring x, so it's going off to positive infinity. This isn't going to be as big, so positive infinity is going to rule here, and so the square root of that's still going to positive infinity, but the first term is going to negative infinity. So you have this minus infinity plus infinity business, and that's bad news. You can't tell what's going on just from looking at it. So it's going to mean more work, and I expected everybody to do this, and the right move is that you want to multiply and divide by the conjugate of this to make it look better. So you're going to multiply and divide by x minus that radical. So we did it there, and we have to do it down below. And the reason we do this is because this is an instance of the rule for factoring the difference of two squares, a squared minus b squared. Because whenever you have a squared minus b squared, it's a minus b times a plus b. So when you have an a being played by, the role of a being played by x and the role of b being played by this radical, so you have a plus b, a minus b, this is going to come out to be an a squared minus b squared thing, and that's very good because that's going to make the radical there go away. So this limit is, as x goes to negative infinity, the first thing squared, that's just x squared, minus the second thing squared. So the radical goes away, but please replace the radical by parentheses, because it's the whole thing, x squared plus 2x, that's got to be subtracted. The denominator, unfortunately, you're stuck with. Okay. And now this is looking good because you obviously have an x squared that's going to cancel, and this will give us the limit as x goes to minus infinity of just minus 2x over x minus radical x squared plus 2x. And really I thought this was the end of the problem. I thought, okay, now the answer is going to be obvious. No such luck. As x goes off to negative infinity, minus 2x is going to go to positive infinity. So the top is blowing up. The bottom, however, what's it doing? As x goes to negative infinity, this is negative infinity. Inside here, that x is being squared, so this is getting large positive. The 2x isn't nearly as big, so x squared is going to dominate. So this is going off to plus infinity, but we're subtracting it. So it's minus infinity, which is going off to minus infinity. So we have an infinity over minus infinity, which is also bad news. The numerator is trying to make the fraction big. The denominator, I don't care if it's negative, is getting big, which wants to make the fraction go to 0. So you have a battle here going on between top and bottom. And whoever's going faster is going to be the one to win. Or if they're both going at the same rate, there's actually going to be a limit. So what I'm saying is that this is bad news. We're nowhere near being done. So we need another trick. It would be a bad move to multiply again by the conjugate, because all you'd end up doing is going right back to where you started from with this term. So the thing to do here is to multiply top and bottom by 1 over the highest power of x, which is going to be 1 over x here. So I'm going to multiply top and bottom by 1 over x. So this is going to give us the limit as x goes to minus infinity of 1 over x times that is minus 2. That's looking good. Down below, 1 over x times x is 1. And now I've got a problem. I've got to take this 1 over x and bring it under the radical to make anything good happen. And my usual trick here is that I want to write 1 over x as the square root of 1 over x squared, which normally is true, but it's not quite true here. It's a very subtle thing. What is x in this problem? In this problem, x is a number that is going off to negative infinity, which means that x all by itself in this problem is a negative number. So 1 over x is negative. When you write this radical here, you always mean the positive square root. So this is a positive number on the right side of the equation. If you meant the negative number, you would have to stick a minus here. And in fact, that's what I'm going to have to do, because it's not possible in this problem to have x go to negative infinity and have 1 over x equal a positive square root of anything. So I've got to make this the negative square root to make this a true sentence in this case with x going to negative infinity. So that means that I'm going to take this 1 over x and replace it by this minus square root, which means that that minus that's here already is going to turn to a plus. And now we have the radicals. The radical gets multiplied through. 1 over x squared times x squared gives me 1, plus 2x over x squared is just 2 over x. And at this point, we're about done, because as x gets off to infinity, I don't care that it's negative infinity, this quantity is going to 0 right in there. 2 over x is going to 0. So that means 1 plus something that's getting small is going to get close to 1. Square root of that is going to get close to the square root of 1, which is 1. So the bottom is getting close to 2. The top is constantly negative 2. So the limit of this is negative 2 over 2, or negative 1. So as x goes to negative infinity, we have a horizontal asymptote of y equals negative 1. A very nasty problem, but don't blow off this problem just because I wrote it off and gave everybody credit for it. The tricks that you need to do are all in this problem. It's just that they will not be given to you all in one problem in the future, but you do need to know all of them because they come up a lot. All right, problem 3 says to find all the horizontal and vertical asymptotes for this function y equals 1 plus x to the 4th over x squared minus x to the 4th. So let's focus first on horizontal asymptotes, since that's the main subject. For the horizontal asymptotes, we want to know what is the limit as x gets large, plus or minus infinity. So I'm going to go to plus infinity on this of y being this, because I don't want to write the whole mess out. So what's happening as x gets large? Well, clearly the numerator is getting big, x to the 4th, right? And the denominator is going off to negative infinity, because this minus here is going to make the x to the 4th term become negative huge. X squared isn't going to matter too much, relatively. So the denominator is going off to negative infinity. Numerator is going off to plus infinity. That's bad news. So we're going to have a trick, and the trick is pretty clear. We're going to multiply top and bottom by 1 over x to the 4th. So this is going to be the limit as x goes to infinity of 1 over x to the 4th distributed through gives us 1 over x to the 4th for the first term, plus 1. And then on the bottom we have x squared over x to the 4th, which is 1 over x squared, minus x to the 4th over x to the 4th, that's 1. And this becomes a very easy limit. As x gets large, clearly that guy goes to 0, that guy goes to 0, and we're left with 1 over negative 1, or negative 1. Notice that I don't really have to do any more work for the horizontal asymptotes, because when x goes to negative infinity, think about it, x now being raised to the 4th power, being raised to the 2nd power, it's all the same as what happened when x was going to plus infinity, because we're squaring all those numbers. So going to negative infinity is going to give us exactly the same answer. So this function is going to have 2 horizontal asymptotes. The horizontal asymptotes are y equals negative 1 on both sides. So in other words, the function, if you think about it, has a limit line in both directions. Now, I don't know any more than that. It could come in like this, or it could come in like this, but it's going to approach that line both that way and that way. Again, I don't know which way it's going to come in, but it's got to approach y equals negative 1 as x gets large, either positive or negative. Okay, what about vertical asymptotes? Vertical asymptotes occur where the function blows up, where the limit is infinite. The numerator in this expression is always positive. Can't even make it 0. So the numerator is not a problem. The denominator can be 0, however, and most of you could just look at that and see, well, x equals 0, obviously. But it's a good idea to solve the equation x squared minus x to the 4th equals 0. And the way to solve equations is to factor. So I can pull out an x squared common factor, leaving me with 1 minus x squared. And I can factor some more. This is the difference of two squares. So I get x squared times 1 minus x, 1 plus x. And from there we can see that there are three solutions: x equals 0, x equals 1, x equals negative 1. All three of these will make the denominator 0. Meanwhile, the numerator won't do anything. It'll just be 1 or 2, but it's certainly not going to be anywhere near 0. So the denominator is going to 0 in all three of these cases, but the numerator is not doing anything about it. So the denominator rules, causes the function to blow up because the denominator is going to 0. So at each of these 3 points, we have a function blowing up. So we have 3 vertical asymptotes, one at 0, one at 1, and one at negative 1. So you can draw 3 dotted vertical lines to represent that idea. And then later when you get to graphing it, you know that those are vertical asymptotes. Similarly, you could even put the y equals negative 1 horizontal asymptote in here. At the moment, we don't have any tools for really drawing this graph, but in a couple of weeks, we're going to have quite a few tools to do this right. Okay, that's enough for quiz 7.